Hello there guys, welcome back to another epic Inexorable maths video. In this video we're going to go through this integral right here. This is one of two integrals that are done with a trigonometric substitution that you just need to have seen. Because it's really difficult to know how to do this if you've not seen it already. Okay? So it's just really worth having seen it, having someone shown it to you, because this is a very difficult integral to just do. Okay? And the reason for that is because the substitution that you need is quite random. So you might say, oh, it's substitution, so maybe I'll let x equal, or maybe I'll let u equal x squared, or maybe I'll let u equal 1 minus x squared. Or maybe I'll let u equal the square root of 1 minus x squared. But actually, none of those are right. We're going to use trigonometry. Even though it doesn't look like it needs it, where's the trigonometry there? There isn't any. We're still going to use trigonometry here. So let's just dive into this integral and see what happens. I know it's a little bit weird, but this is how it's done, okay? And I'm going to, by the way, this substitution, it might seem random, but this substitution is so good that it will turn this integral, which is moderately complicated, into the integral of the number 1. Which is basically the simplest integral that you could possibly imagine. So it's a very, very good substitution. Okay, so the substitution is going to be, we're going to let x equal sine, and we're going to make up a new variable. I'm going to call it theta. You could call it u. I'm just calling it theta because it's an angle. So theta is a new variable, and I'm going to say x is sine theta. I know how random that looks. This is why it's a difficult question if you've never seen it before. So with that, let's see what d theta is. So dx d theta will be cos theta, of course. Okay, and that means that dx would have to be cos theta d theta, like that. Okay, now let's actually fill everything in. So our integral, which I've labelled I, is just going to be the integral of 1 over the square root of 1 minus, x is sine theta, so sine squared theta. Okay. And dx is cos theta d theta. So cos theta d theta, like that. Now you might say, well, it still looks tremendously complicated. It actually looks worse than how it started. But guys, we're going to simplify this using a trigonometric identity. That identity is going to be the fact that cos squared theta plus sine squared theta is equal to 1. Okay, this is the Pythagorean trig identity. We're then going to take sine squared away from both sides. You'll see why in a second. So we have that cos squared is 1 minus sine squared. And the reason we've done that is because you see how we have a 1 minus sine squared right there. Okay. Then we're going to square root both sides to get cos on its own. So we have that cos is the square root of 1 minus sine squared. Now, some people say, shouldn't that be a plus or minus the square root of 1 minus sine squared? Because you just take the square root, but it's plus or minus, right? And the answer is yes, it is plus or minus. Yes, cos theta is plus or minus the square root of 1 minus sine theta, because cos can be negative. There's obviously times when cos is negative, right? But I'll answer that question at the end. Let's finish the question, and I will explain to you why you don't need a minus in front of that square root there. You don't need it, although mathematically, this is not an identity, because you would need a plus or minus. But in this question, you don't need it, and I'll explain why at the end. So let's just finish this off. Now, if we simplify this integral a little bit, we will have the integral. Now, the square root of 1 minus sine squared is just cos theta. So we have 1 over cos theta multiplied by this other cos theta, which I'll just put at the top here. So we have a cos theta divided by a cos theta. Now guys, what is anything divided by itself? It's just the number 1, obviously, isn't it? So this is the integral of the number 1 integrated with respect to theta. Now what is the integral of 1, guys? You might say x. It's not x, it's theta. It's theta plus c because we're integrating d theta with respect to theta. So this is theta plus c, okay? We're almost there. The last thing that we need to do is replace theta with what it is in terms of x. Now we said that x was sine theta, so that means that theta on its own is going to be arc sine x, just by rearranging that equation, taking the inverse sign on both sides. Some people prefer, instead of arc sine, they prefer to just use sine to the -1, like this. So the answer to this integral is that the integral of 1 over the square root of 1 minus x squared dx is actually arc sine x plus c, which is really random, right? But as you can see, it's kind of a standard integral. It's kind of something that you need to know. The function that integrates to arc sine, it's a big deal. So that's kind of how you do it. And now I'm just about to answer this question about the plus or the minus. Okay guys, so to finish off the video, I'm going to explain to you guys why the cos theta equals the square root of 1 minus sine squared theta. Why is there no plus or minus right there? Because there technically should be, but you don't actually need it for the question. Why is that? This is the way that I would explain it. On the original integral, x has it's only able to take values between -1 and 1. Right? Because if x was outside of that interval, you'd have 1 minus something larger than 1, which is negative, and you're taking the square root of it, which you can't do unless you want a complex number, which we don't want. So x has got to be in this interval, and x is equal to sine theta. So, and I'll explain these numbers in a second, but that means that theta should be between pi over 2 and minus pi over 2. Okay, now the reason for these numbers is this. If you look at the graph of sine between pi over 2, which is the same as 90 degrees, and minus pi over 2, this here is a minimum, this is a maximum, so this is 1, and this is -1. So all of the values that you need, as long as theta is between minus pi over 2 and pi over 2, you're actually fine. So you can just do the integral, and normally we don't think about this. We don't, normally when you say let u equal blah, 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 you don't tend to care what specific numbers u is able to be. But in this case, it's actually really interesting. It's a good thing to think about it, because in order to do this entire question, theta only has to be between minus pi over 2 and pi over 2. That's all you need, because the domain of x, what you're allowed to put into this function, is quite small. And because of that, because theta only has to be between these two values, then when you take cos theta, well, cos of any value between minus pi over 2 and positive pi over 2 is a positive number, because the graph of cos between minus pi over 2 and pi over 2 just looks like that. And obviously, it continues, it goes like this, it goes like this, but we don't care about these negative bits. We only care about from negative pi over 2 to pi over 2. So it's positive the entire time, which means there's no reason for you to have a minus there, because cos theta is always positive in this interval. And this is the only interval we care about. Therefore, you don't need a minus. That's all it is, basically. It's nothing too deep, nothing too crazy. Anyway, guys, thank you so much for watching. I highly appreciate it. Hope that makes sense, and I'll catch you in the next one.